Today we're talking about hyperbolas. You'll notice similarities here. We have a center, just like we did for our circles, just like we had for our ellipses, and you also have a center on hyperbolas. Hyperbolas also have vertices, which is similar to ellipses, and these also have asymptotes, and we're going to talk about those and what those are, and then you're going to sketch these. Okay, a hyperbola has two asymptotes. We don't abbreviate asymptotes, we say the whole word. Okay, a hyperbola also has two vertices. The difference here, remember when we were finding our vertices on ellipses, it was the longer side. You guys remember that? With hyperbolas, it is always on the side that comes first. What I mean by that is if you look down here, in hyperbolas, there's two different equations. Do you guys notice the difference between these two equations?
A and B squared.
Yeah, and I mainly kind of focus here. See how this one starts with an x squared term?
Yeah.
That means the vertices would be on the x-axis. This one starts with a y squared term. Therefore, your vertices would be on the y-axis. The equations of an ellipse and a hyperbola are very similar. Okay? So if you go back and look at your ellipse equation, it looks almost exactly the same as your hyperbola equation. Does anyone know what the difference is? If you go and look, this equation has a plus in the center. Hyperbolas have a minus. So anytime one of your squared terms has a minus in front of it, you know it's going to be a hyperbola. Okay? Okay. So again, our center, anybody have any idea what the center is going to be? H, comma, K. Just like it was on our other shapes. Hyperbolas have two different equations, but the center is always H, comma, K. So you need to remember that your H value always goes with the X and your K always goes with the Y. So on this one, when Y comes first, make sure that you're still putting it with the Y part in your center. Okay, don't get confused that since it comes first, it's going to be the X value. So Y's go with the Y value, X's go with the X value. Okay, notice that the equation for hyperbola has a what? What does it have? Minus or a negative. You can write whatever makes most sense to you there. Between the x squared and the y squared equations. Okay? And then I just talked to you about this, but if x is first, the graph goes right and left because the vertices are going to be on the x-axis. Okay? If the y is first, the graph is going to end up going up and down, and again, it's because your vertices would then be on the y, and this will make sense when we start graphing. To find your asymptotes, you will use the following equation. Y equals plus or minus b over a. Where do b and a come from? So we know how the b lines up with the y and the a lines up with the x. Yeah? So notice this is really like this. You can think of it as rise over run. It's always like your y value over your x value. Okay? So what we mean by this b over a, it's the y over the x, rise over run. Okay? And just like with ellipses, hyperbolas should always equal 1. If they do not equal 1, then you divide so that the equation is equal to 1. Okay? All right, so let's go ahead and try to put all this stuff together. Example 1. Okay, the first thing we're going to do is find the center. The center is usually pretty easy to find because we're just looking at the top with our x and y. Okay, so what is my center on this? 0, 0. So let's go ahead and plot that at 0, 0. Okay, focus please. Okay, now let's go ahead and do what we did with our ellipses and figure out how far we need to go out on each of the x's and how far we need to go on each of the y's. So on my x, we're going to take the square root of 16, which is 4. So I'm going to go up and down 4 on the right and left 4 on the x-axis. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, then we're going to go to the y, and I'm going to take the square root of 25, which is 5. So that means I'm going to go up and down 5. Okay. Now, which letter came first? X. So my vertices are going to be on the x-axis. And I might go ahead so I don't forget. Right here, I'm going to put an X here to remind myself that my vertices are on the x-axis. Okay? So if you go, what are these points here on the x-axis? 4, 0, good, and negative 4, 0. Okay, so we have all that. When you are making a hyperbola, you are going to end up making a dotted box. This is going to help you with drawing. So I'm just kind of doing a dotted line, and I'm going on the outside and making a box around these points. Okay, from there, after you do that, you are going to draw your asymptotes. Your asymptotes are lines. That's why they are written as y equals b over a, or plus or minus. So my asymptotes, my equation is actually here, y equals plus or minus, and they said b over ax. Well, we remember that as actually y over x, right? So that's going to be plus or minus what? 5 over 4x. That represents a line. Okay? And you don't actually have to make the lines, figure it out on here. All it is, because if you go up 5, right 4, you'd make a point. Your lines are just diagonal through the box corners and your center. So right there, I just graphed my asymptotes. So it is just an x. It is just an x through the center, and there's 2 lines. Remember when you're reading a line, if you want to know if it's a positive slope or negative slope, you start from left to right. If you start here, see how this one is going up? That's my positive asymptote slope, and this one right here is my negative asymptote slope. So this is actually representing 2 different lines, your positive line and your negative line. Okay? And this is the equation for both of those lines. Now, what happens with an asymptote? It's basically, I kind of think of it as a magnet, and it's keeping a graph inside. It can't touch the line either way. Okay? So what happens is, and I'll show you how you graph this, where were my vertices, on the x-axis or the y-axis? X. So these are 2 parabolas going to the left and right. And so when you make your curves, they are next to the asymptotes, but they never go over them. So the asymptotes basically keep these curves inside the graph.
I feel like there's a shortcut.
What? The curves are actually the hyperbola. So this is a graph for a hyperbola.
Wait, does it say to find a hyperbola?
What?
Does it say to find a hyperbola?
Yeah, why did you do that?
It says identify the center, vertices, asymptotes, and sketch. So that's what we did. We found the center, the vertices, the asymptotes, and we sketched it.
So the hyperbola.
So was it necessary?
This is the hyperbola sketch.
It was necessary. It was necessary. So we have to draw the little halves of moving thing.
Yes. That's your answer. That's it. All of this is your answer.
Are the vertices always going to be X?
No. Where are the vertices going to be? Who remembers? Shh. Whichever one comes first. So when we get down here, do you see? Let's go ahead and try example 2 and see how you guys do. Do you see how the Y comes first here?
So to be, oh, okay. So to be Y.
So that's why I'll go and write Y here to remind myself, okay, Y came first, so my vertices are on the Y-axis. Okay? What is my center on example 2?
0, 0.
Very good, 0, 0. Okay, so we can go ahead and plot 0, 0. Once I plot 0, 0, then I'll usually find how far I'm going to go on my x-axis and how far I'm going to go on my y-axis. So my x value, if you notice my x value here is 16 underneath, right? So all we do is take the square root of 16, which is 4. So on my x-axis, what am I going to do? 4 to the right and 4 to the left. 1, 2, 3, 4, make a point. 1, 2, 3, 4, make a point. Then we figure out how far to go on my y. So on the y part, it's the square root of 9, which is 3. So what am I going to do now? Up 3, 1, 2, 3, and down 3. The hyperbola is the graph they're going to end up making a little box around your outside points. So you're going to go ahead and make a dotted box around your points. Okay, who remembers how you end up drawing your asymptote lines? Through the corners and your center. So it's just dotted lines here through the corners and your center. Who remembers how to write the line for your asymptotes? Y equals plus or minus 3 over 4, because it's your y value over your x value, and then you have to end it with an x because that makes it a line, because that's the slope. Okay, and it started at 0, 0, right? Okay, now you said your vertices are on which axis? The y-axis, because the y came first. So what are my points on my y-axis? 0, 3, and 0, negative 3. And then your last step is to draw your curves, and this time they're going up and down because my vertices are on the y-axis. So on the last one, my curves went right and left because my vertices were on the x-axis. This time they're up and down because my vertices are on the y-axis. It's not that bad.
They did. I showed up late.
Right. On the ellipses, it was always whatever the longest side was. But this one, it's whatever's first.
Pretty good, yo. You missed out, man.
Okay? Yes. Shh, I can't hear the question when you guys are talking. The asymptotes, the lines.
Are those always going to be like little dotted lines, or are they ever going to be like solid or something?
They're pretty much always going to be dotted because basically it's almost like they're imaginary, but they're keeping your curves inside. It's like having that magnetic thing where the curve has to stay in there. But I mean, if you drew them with straight lines instead of dotted, it's okay that you would write it that way. Okay?
So it doesn't, never mind.
As long as you have them there, that's all that matters. Okay? All right, you guys ready to move on? Okay. Okay. So again, you need to be careful on example 3 because sometimes people think that they're going to take the square root of 9. Okay, but you're not. I would suggest getting rid of these parentheses so that you do not make any errors. Okay, what do I mean by that? When you have a squared term outside of a parenthesis, this square is going to each thing in here, right? So I'm going to rewrite this as x squared over 81 minus y squared over 16 equals 1. Okay, and then you'll end up square rooting it, and you'll end up getting back to the 9 and the 4. But if you do this first, I found that on the test, a lot of people just take the square root of 9. And they do that on purpose because they want to see if you're really paying attention. And they'll take the square root of 4, and that would give you the wrong numbers. Okay, and the whole problem would end up being incorrect. Okay, so what is my center on this problem? Very good, 0, 0. My vertices, are they going to be on the x-axis or the y-axis? X. And why are they on the x-axis? Very good. Okay, so let's go ahead and plot our center at 0, 0. My x value, I have to take the square root of 81, which is 9. So on my x-axis, I'm going right 9, and I'm going left 9. On my y-axis, I am taking the square root of 16, which is 4. So that means I'm going up and down 4. Okay, what is my next step?
Gotta make that square.
Good. Make your little box
Yeah.
or square or rectangle, whatever you want to say. And why I make these as dotted is because they're not really there, but they help you to make your curves and everything correct. Okay? So when you see a hyperbola graph, you normally see the box and you see the asymptotes that keep your curves in the area that they're supposed to be. Okay? So now once I have the box, what's the next thing I should do? Draw your asymptotes, and they go through the center point and the corners of the box. What is my equations for my asymptotes?
4, 0. I mean, no, 9, 0.
Okay, y equals plus or minus 4 over 9x is correct. Are we all okay with where we're getting that equation? Good. Okay, my vertices, we wrote, my vertices are on my x-axis. So what are the points on my x-axis? 9, 0, and negative 9, 0. Very good. Which means which direction will my curves be? On the x-axis. So they're going right and left. So there's my curve. And we're done. Okay. Yes, question.
So it depends, so if your vertices for the x's, then the little half of the thing is gonna go on the outside.
Yes. Okay. Example 4, what's different about example 4? There's not a 1 at the end. How do we make it so there's a 1 at the end? Very good. We're going to divide everything by 36. Okay, when I do that, we can reduce. And so I end up getting y squared over 9 minus x minus 2 squared over 36 equals 1. Okay, what is my center on this graph?
1 and 2? No, 0 and 2. 2.
Very good, and this is where you need to be careful. Okay, and I appreciate how some of you are paying attention. The x value, because this x minus 2 is the x value, is 2, and the y value is 0. Because we always take the opposite of what's in parentheses. And just notice that that x one is the one that was different. Yeah, it's just okay, my vertices, are they going to be on the x-axis or y-axis?
Y.
Good, on the y. And how do we know the vertices are on the y-axis? Very good. Okay, so let's go ahead and plot our center. We're going right to up 0. What's wrong? Okay. So now, how far am I going to go on my x-axis?
6.
Very good. Square root of 36, which is 6. So we're going to go right 6. 1, 2, 3, 4, 5, 6. We're not in the center this time. Our center is at 2, 0, not 0, 0. So from your center, you're going right 6, and then we're going left 6. So we have 1, 2, 3, 4, 5, 6. Okay. My y, we take the square root of 9, which is 3. So again, from my center now, I'm going up and down 3. 1, 2, 3. And 1, 2, 3. Now what will I do?
Make a rectangle.
Okay, go ahead and make that box around it, or rectangle. Then what? Do your diagonals, your asymptotes through there. Where were my vertices again? So I'm going to make my curves going On the y-axis, up and down. Very good. So this one curves up like this. This one curves down like this. And did you guys find the vertices? That is not correct.
2, 3, 2, -3.
Very good. This point is right 2, up 3. And this is right 2, down 3. So 2, -3. So make sure you're really paying attention to where these points are if your center is not at 0, 0. Okay, so your asymptotes would be at
Are you allowed to reduce that?
yes. So that's actually going to be y equals plus or minus.
Do you have to reduce it?
You should, yes. And this asymptote is not the exact correct answer because it's not plus 0 here. It looks like it's plus a +1 and a -1. Do you guys see that?
No.
You know what? Don't worry about it. We're just gonna, you really just need to know the slope. So we're just gonna not talk about it. Okay. Anyways. Okay, the last thing they want you to do is put these hyperbolas into standard form. I have an error on your notes. This should not be +4. This should be a plus, hold on, 16 right here. Okay, so do you guys feel okay at the graphing part?
Yeah.
Okay. All right. So putting them into standard form or descriptive form is what we're actually going to do. What do you think we're going to have to? Good. You're going to have to factor out a 4. So we're going to factor out a 4 with the y's, and we get y squared plus what?
4y.
4y, because I told you that was 16, right? And then plus a blank.
Oh, we're completing the square again?
Yes. And then, do I need to do anything with the x squared? No. So, but I have the minus x squared, right? Equals 0. And then what do I need? Plus,
4. You have to do +4 times the blank.
exactly, plus 4 times the blank. Very good. Okay, what's my next step on completing the square? Not 16. 4, because we took out the 4, so we're taking 4 divided by 2, which is 2, and 2 squared is 4. So 4 goes into each of my blanks. And then when I write this now, I have 4 parentheses, and what does my square become? Y plus 2 squared minus x squared equals 16. Okay. Then what do I need to do? Divide by 16 because you want it to equal 1. So we divide by 16 and reduce. So my equation is y plus 2 squared over 4 goes into 16 4 times, that's 4, minus x squared over 16 equals 1.
Where'd you get 4 from? Oh, no, y plus 2.
Because remember I had a 4 out in front here? So I'm just reducing the 4 and the 16. 4 over 16 reduces to 1/4, right? So that's, I just was reducing. Okay. Example 6. So again, we're completing the square. This time though, they have things kind of like mixed up in the problem, right? So I have a 4y squared, and then I have a plus 40y, and then this negative 17, what needs to happen to it? To the other side. Also notice that the x squared term is negative, so that one's going to be the one that comes second, right? So we're going to start with our positive, and what will I need to do first to complete the square on this one? Take out the 4. So I have 4 parentheses y squared, and when I divide 40 divided by 4, I end up getting what? Good. Plus 10y plus blank. Okay, then we move on to our x's. Okay, so for my x's, I'm going to have, what am I going to do? take out a negative 9 parenthesis, and we have x squared. Now this is where people make a mistake. We are taking out a negative 9, which means I'm dividing this by negative 9. And a negative divided by a negative makes a positive 6x plus blank. Okay? Equals, and what does it equal?
17 plus 4 times blank, or minus 9 blank.
Very good. Questions right now? Okay, now to complete the square, what do I do? Okay, so 10 divided by 2 is 5, and 5 squared is 25, so 25 goes in each of these blanks. Then we have 6 divided by 2 is 3, and 3 squared is 9, so 9 goes in each of these blanks. So we'll write our equation. I have 4. What is this y squared plus 10y plus 25 factor to be? Y plus 5 squared. Then we have minus 9, and it's going to be what? Very good. X plus 3 squared equals, and we need to simplify all that. So I have 17 plus 100 minus 81. And when you simplify that, it equals 36. Okay? And this is our standard form, but we really want a descriptive form. And what do I do to finish that up? Divide by 36 every term. And so on this one, we have 4 over 36. So that reduces to 9 in the denominator. So I have y plus 5 squared over 9. Minus 9 goes into 36 4 times. Good. So I have x plus 3 squared over 4. And then it equals 1. And there's my answer.
When did you add the 17 to the other side?
Oh, just when I was, so right here, I just kind of told myself that it's negative 17, so I move it to the other side. It becomes positive 17. Okay. Lastly, at the bottom, it says to write the equation of the asymptotes of the following parabolas. So when they're asking you to do that, you just need to know, well, what is my x value? How do I find my x value? Of hyperbolas, sorry. How do I find my x value? Good, square root of 81, which is 9. My y value is going to be the square root of 49, which is 7. So what's my equation?
Y plus or minus 7 over 9.
Yes. Okay. When we have the parentheses, what should I do first? I would, square everything. Rewrite the equation. So this is going to actually be y squared over 9 minus x squared over 16 equals 1. So my x value is the square root of 16, which is 4. My y value is the square root of 9, which is 3. So the hyperbola or asymptotes of the hyperbola will be y equals